Hello and welcome to the Deep Cuts companion episode. All those snippets that couldn't fit into the regular show can be found here in all their glory. Enjoy.
You're listening to Encyclopedia Podcastica, a podcast from the Silicon Valley skeptics. Prepare your mind.
About planets. Well, first, we need to talk about where the name planet comes from, I think. I think that's important to define planet.
If we're going to hunt them, we got to know what they are.
Right, or at least how to name them. Or something. Well, the name actually comes from ancient Greek, and it means wandering star. And that's a
That
reference.
is not what a planet is.
Right, but if you look up at the night sky, the planets look like they're little stars wandering around. They're not fixed.
Yeah. They go into retrograde, and then all the people that believe in astrology are like, "Oh my God, Mercury's in retrograde." And all us normal people are like,
"What?
Okay,
Whatever.
It doesn't matter. It's millions and millions of miles away from us, and it's not going to hit us, so it doesn't really matter."
Right. Sure. So, because a number of the planets that orbit our sun are actually visible from Earth with the naked eye, I don't think we actually know when the first ones were found. Those are local planets.
There wasn't like some commenter that was like, "First."
No, there wasn't a first. Like, there wasn't, Ptolemy wasn't like, first planet.
It would be way before Ptolemy, right?
Yeah. Well,
Yeah.
it was just, that was the first name that was on my list here.
There wasn't some like Australopithecine that was like, first. Could they talk, Australopithecines?
I don't think so.
Then it would just look
Maybe.
up at the sky and go, "Rrr,"
Rare. Maybe a grunt.
translated to first. Speaking of things that are totally named wrong, I learned the sign for star the other day.
Yeah.
In ASL, and it's like you point your fingers up, you put your hands in front of you, and you point your index fingers up, and then you move them around like they're shooting. So it looks like a shooting star, but that's the term for star.
Just regular star.
And shooting stars are not stars.
Right. Which are also poorly named.
But then again, we call them shooting stars in English too. So
I guess it's fair.
yeah.
Right.
All languages have these terrible naming things.
Right.
Oh well.
Well,
If
the
only we
ancients,
could go back.
the Greeks, and all those people didn't know that planets that they could see with their naked eye were not stars. They just thought they were like weird wandering stars. They called them planets. That's where we get the name from. And it wasn't until much later that we figured out that they actually like orbit and stuff.
Who figured that out?
Well, first, it was Ptolemy that I think came up with the idea that, no, he actually thought that they orbited Earth, which is not, we know is not true.
Oh, so they didn't burn him at the stake.
No, it wasn't until, the idea was actually around for a while, but it wasn't until Galileo that we actually have supporting evidence, because Galileo, of course, had telescopes, could actually like look closely at the planets and see what they were doing. And I'm sure, are you going to go over the what he did to determine?
I'm not, so you should
Okay.
probably talk about it.
Well, I don't actually have any of my notes, so.
Well,
I
he
mean,
did.
but
He did determine that there were things orbiting other things. He saw the
determined that
moons
things
of Jupiter
we're orbiting
them.
other things, and of course we know, like, the moon was orbiting Earth, and I believe.
But at that time, we
figured
thought
out,
everything was orbiting Earth.
right. But what I think one of the big pieces of evidence that he found, that he can only find with a telescope, is that the planets actually went through phases, like the phases of the moon.
That makes sense.
Right.
Yeah.
I think that was his big, among other things, that was one of the big giveaways.
Explain that, Catholicism.
Well, they didn't. They just killed him.
Aw.
They didn't. He was put under house arrest, and he recanted his beliefs
Yeah.
in order to stay alive.
So they just
Oh, that's right.
basically tortured him.
They threatened.
They threatened to kill him. That's right.
Kill him, and he recanted. So that didn't.
You
Forgot about
better
that.
stop believing that stuff.
You better stop
Okay.
saying that stuff.
Yeah.
There's a difference.
It actually gets more complicated than that because it has to do with he was saying that stuff and he told him not to say it, and then he kept saying it, and he actually ended up writing a book where he basically made fun of the Pope, and that kind of pisses off the Pope. And
they were worried that, if there are other planets, are there other popes on these other planets? And he said, sure. And that created some controversy.
Yeah.
Jovian Pope.
Jovian Pope.
You can't have
Saturnian Pope.
only one dude gets the pointy hat.
Martian Pope. I would think that the Jovian Pope has a pointier hat
That's the
than the Terran Pope.
That's the problem. The Pope here wants the pointiest hat. and if there's a Jovian Pope with a pointier hat, he's going to be angry or just want to steal his hat.
So they killed Galileo for that.
They didn't kill Galileo.
They didn't kill him.
They tried.
They just put him under house arrest and
They killed his spirit.
Yeah.
okay,
We can go with that.
fair enough. Okay, and then after Galileo proved that they orbited the sun, thought they were in a actual circular orbit around, but Johannes Kepler, who his name will come up later, but he proved or noticed that the orbits were not circular; they're actually elliptical. They're not a perfect circle; they're a little bit of an ellipse. And I don't know how that works anymore. I used to know. No, I know how an ellipse works, but I don't know why it's an ellipse. It's
because the closer it gets to the star, the faster it's falling towards the star, and it'll fall towards the star really fast at the close point, and that flings it back out further.
Okay, but it never equalizes a bit so that it ends up being perfectly circular. Like it never.
No,
because
there's nothing there's nothing to slow it down,
right?
Because it's in a vacuum, the vacuum of space.
Okay, even in the darkest vacuum of space, there's still some matter that would actually slow it down. But
technically, it would take billions of years, and also there's gravitational radiation.
Okay,
which it would just fall in because of gravitational radiation, unless it's doing something like what the moon is doing, where the moon is getting further away, because the moon builds tides on Earth. Like there's tidal force on Earth, which causes Earth to elongate, pointed towards the moon. But Earth is also spinning in the same way that the moon is rotating.
Right.
So the tidal bulge caused by the moon will spin a little bit ahead of the moon, and that extra gravity on that side of the planet tugs on the moon just a little bit more.
So it
gets faster and faster by stealing our angular momentum.
Right, and the day is getting longer and longer at the same time.
Yeah,
by tiny amount.
Yep, by I think it's something like a millisecond per century or something.
Wow.
Yeah.
Well, thanks for that.
It's a very small amount.
That's why you're the science guy on the on this podcast. But I want to talk about some of the planets, the close planets.
You should call me the Science Baron.
Science Baron?
I'm Hunter Perrin, the Science Baron.
I like that.
Don't ever call him that.
I'm not so sure about that name.
I've already had business cards printed up.
I was going to say, if you call him that once, he will get business cards, and that's the problem.
Oh, fuck yeah.
Right. And
I'll get a lab coat.
Why would a baron have a lab coat?
A Science Baron would.
Oh, okay. Would it have medals or something on the...
Hell yeah. Science medals.
Science medals.
I just need to earn some science medals.
Right. First place at science fair.
Do some science.
I know people that make coronets. We will make you a science coronet.
Fuck yeah.
That's pretty cool.
So you were talking about Johannes Kepler.
No, I was going to go on to actual planets.
No, the most recent thing with Jupiter that's my favorite is they've named the moons after his mistresses.
I was just about to get to that.
Okay.
So, as Galileo discovered 4 of the moons, the 4 biggest moons of Jupiter, named them Io, Europa, Ganymede, Callisto. They're all named for Zeus's lovers, which
Europa's the sexiest.
I did not know that.
Yeah.
But I
you
wanted,
looked at
I
Europa?
wanted to point it out. I wanted to point out that this is yet another instance of Galileo mixing Latin and Greek. This is why he was persecuted, as we discussed earlier. It was actually astronomers Giovanni Borelli and Cassini were using orbital tables and mathematics tracking Jupiter and discovered that, according to their calculations, it appeared in opposition. Jupiter appeared in opposition to Earth about 17 minutes behind their calculations. And it was from this and many other things that showed that light was not actually instantaneous, that it actually took time for it to travel. Apparently it takes about 17 minutes.
It took that long for us to figure that out?
Yeah.
People are dumb.
I mean, it's not something obvious.
It's not something you could really do. I don't think the Greeks could do
That's
it.
true. It isn't really obvious. It's obvious with sound, but it's not obvious.
No, it's not. I mean, light is
with light.
so fast, so much faster.
Oh, something else funny about the name
Jupiter?
Jupiter.
Oh.
Did you see that meme recently that we sent Juno, the probe, to Jupiter,
Okay.
which we named after Jupiter's wife?
So go check on him and his mistresses.
Right.
That's what I was getting excited about, but you ruined it for me, Hunter. I hate you.
I'm so sorry.
Do you know the Greek counterpart to Juno?
What?
Hera.
Hera.
Is that where we get harem from? Probably not.
No, I think that's an Arabic word.
Yeah, that's... It sounded right.
This is not an etymology podcast.
It
I'll shut
should
up.
be.
So moving on, we got Pluto next. And actually, in 1906, Percival Lowell he started a search for planet X because he noticed Uranus's orbit was being disturbed by another planet besides Neptune. But it wasn't actually discovered until February 18th, 1930 by Clyde Tombaugh. And it turned out it actually didn't fit the calculations for Planet X, even though all these people were looking for it, or trying to find this Planet X, and we found something that looks like Planet X, but it didn't fit. It was too small. But it later turned out, when the calculations for Planet X were looked at again, that Planet X didn't actually exist. So,
And now it turns out there might be a Planet X.
Is there? Really?
Yeah.
Oh.
There's a new calculation that is based on the orbit of a bunch of Kuiper Belt objects
Okay.
and suggests there might be
An actual
another
planet.
big planet.
Okay.
Like
Because-
bigger than Earth.
Talking about the Kuiper Belt, originally Pluto was thought to be the 9th planet from the sun, but by 1992, its status was in question because of other similar-sized objects found in the Kuiper Belt. And the Kuiper Belt is the belt of stuff that's just way out there beyond Neptune and Uranus.
Yep. Not as far out as the
Uranus.
Oort cloud, but
Not that
further
far
than,
out.
than Neptune's orbit.
Right. There's a bunch of stuff out there that didn't quite become a planet, maybe.
Yeah, there's like a bunch of small icy planets.
Right.
Planet.
And actually, on July
Dwarf
29th,
planets.
2005, Eris was discovered, and it's in the Kuiper Belt, and it's actually bigger than Pluto. So then they had kind of a problem. And in August 24th, 2006, the International Astronomical Union,
IAU.
came up with an official planet classification, which ended up excluding Pluto as a planet, and Pluto got demoted to a dwarf planet.
Do you know why? Do you know like the
Specific
planet
reason?
classification? Yeah.
I actually didn't write down the entire
I can tell
list,
you.
but
So
I know why. But
there's.
okay.
Oh, do you want to say?
The specific reason why Pluto was excluded from the classification was it did not actually sweep all of the other material in its orbit. But you'll go into detail on the classification in the science section.
No, we should talk about it here.
Okay.
So, in order to be a planet, like you said, it has to clear its orbit of other orbital debris.
Right.
it has to be big enough that it can pull itself into a round shape, which Pluto is. Pluto's
big
round.
enough, yep.
And it has to orbit the sun, which Pluto does. Well, kind of. Pluto and Charon kind of orbit each other.
Yeah, that's true.
Because the barycenter of the Pluto-Charon system, the barycenter...
Right. So you want to mention that Charon is Pluto's biggest moon.
Yes.
Ish.
Yeah. And barycenter means the center of gravity that everything in that system orbits. And the barycenter of the Pluto-Charon system is actually outside of Pluto.
Right. On all the other planets that have moons, the barycenter is inside the planets.
Yeah.
Right.
Yeah, like the barycenter of the Earth-Moon system is in Earth.
Right.
So like Earth will wobble around the barycenter, but it's inside of Earth.
Right.
So it just makes little circles in space.
Right.
Interestingly, though, the barycenter of the Sun-Jupiter system is outside of the surface of the sun. It's like just above the surface of the sun.
Wow.
So the sun kind of orbits the barycenter of the
So does that make
Jupiter system
a planet?
It is a planet because it's
it
definitely not big enough to be a star.
Well, yeah.
It's like you'd need to pack like 70 more Jupiters in there to make it a star. And even then it would be a tiny star.
Right. I want to point out that Neil deGrasse Tyson was a big proponent of Pluto's demotion.
He's got so much flack for that.
Yeah. Pluto really didn't like that and fired back, and it caused an interplanetary war, which Earth quickly won.
An interdwarf planetary war.
But Earth quickly won because, nobody lives on Pluto.
That we know of.
Well, they didn't fire anything. We shot multiple probes their way.
Although with that gravity well, they'd be in a good position to throw stuff at us.
That's true.
That's true. Yeah.
But we shot some warning shots, called them probes. They didn't do anything about it.
That comment about the gravity well reminds me of something else that is super fascinating that I would love to share with all our listeners. Did you know that it takes more energy to send something into the sun than it does to send something out into interstellar space?
Really?
Yeah. Because think about it. To get to the sun, you need to counteract all of Earth's angular momentum.
Okay.
To go completely...
Well, the momentum of whatever you're trying to...
Yeah, but
it's going to go speed of Earth.
Yeah. So Earth is moving very fast around the sun, fast enough to not fall into the sun, even though the sun has massive amounts of gravity.
Right.
And we would have to fire a probe like backward in our orbit for long enough to make that probe not orbiting the sun anymore and just fall into it.
Right.
And it's a lot easier to fire a probe the other way and get it just completely out of the solar system.
Did not know that.
That's fascinating.
Yeah. So when people say like, oh, why don't we just fire our nuclear waste into the sun? No, because that takes more energy than just firing it out into interstellar space.
Right.
Or leaving it in New Jersey.
Oh, poor New Jersey.
So back to Pluto.
Oh, poor Pluto.
Oh, poor Pluto. But after it was demoted, Plutoed became the 2006 Word of the Year by the American Dialect Society, which means to be demoted or devalued, which I thought was humorous. So after that, we're done with all our planets in our solar system. So now we're going to... Maybe, except this other planet X, which I didn't know there was actually another planet X that you were talking about.
Well, I mean, it's obviously not confirmed, or else that would be like huge news. But there's speculation, and the speculation has some merit behind it, so it might.
Maybe.
Yeah, maybe.
It's maybe.
It's a definite maybe.
Definite maybe. I actually forgot to mention, I think it was Pluto, when they were trying to find Pluto. I think that's how they found it with the photographic plates, I think. Oh. And what they would do is they would take one photo at one point or one day, I think it's multiple days later, because you have to have enough of a difference. And they'd take another photo, they would overlay them, and then kind of like switch back and forth between, like, you would do like animation cell
and like if everything's
kind of
moving this way and one thing's moving a different way, you're like, that's probably a planet.
Yeah, that's pretty much how it works.
Yeah, so this would be a little different. You'd be looking to see if the star is making circles.
Okay. And you mentioned before you can figure out the size, the radius of the planet.
Mm-hmm.
But couldn't you figure out the mass based on the period of this of these transits? Because that's would determine its orbit.
You don't know its density, so you can't know.
But you know
its mass.
But you know its size, and its mass wouldn't that be related to the period of the orbit? Not, it isn't. No. Okay.
No, it's just the speed of its orbit.
Okay.
Because two planets that are very different in mass can have the same orbit.
Okay.
It's just how much. Because
its distance and the speed would be, and then it would just be a different speed if it was at the same distance from the star.
It could be at the same speed,
but different mass.
Because it's how much orbital velocity it has.
Okay, I'll have to look this up later.
We could probably waifu this section.
Yeah.
Come back to it in the next episode. So we'll move on to our next couple methods. I'm going to combine these because they're both very similar. There's the transit timing variation method and the transit duration variation method.
Okay.
They
sound like identical.
They're
timing,
very
duration.
close.
Yeah. Okay.
One measures the difference in the periodicity of transits, and the other measures the difference in duration of transits.
Okay, you're going to
use those.
Explain that a little better.
So one will measure how often does this transit occur, and if it occurs at different intervals, like if it's bump, 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 more like a heartbeat.
Yeah.
Then we know that there's something else that's interacting with that system.
Okay.
And one measures the duration of the transit. So if the duration of the transit is changing, if sometimes it's longer than other times, then we can also determine that there's another planet in that system.
Okay.
So
this is like for finding second and third planets.
Yes.
Okay.
Yeah. So this is if we already have a planet that's transiting its star, can we find additional planets with these methods? They don't tell us a lot about the planet, though. They just give us like a range of possible masses. Since those planets aren't transiting, we can't tell anything about their atmosphere. We can't tell anything about their size. So, yeah. It's still a pretty cool method, though.
Yeah.
Well, those are all the deep cuts we have. And I hope you were paying attention, because they'll also be on the test.
Encyclopedia Podcastica is a production of the Silicon Valley Skeptics, an organization dedicated to promoting science and critical thinking. You can find us on Twitter at SVSkeptics or Facebook at facebook.com/SVSkeptics. You can contact us at svskeptics@gmail.com. If you like the show, please rate us on iTunes.